This is Lab 1, Part 3, brought to you by Bad Kitties Everywhere. This portion is going to deal with resistors in parallel, much in the same way that we examined resistors in series in Part 2. So I'll be doing a demonstration using a pair of digital voltmeters applied to a circuit to demonstrate the principles of parallel arrays. The demonstration will involve the use of two digital voltmeters. Again, the first one will be run in resistance mode to measure resistance, and in doing so applies a small voltage to the circuit under test. The second meter will be operated in voltage measurement mode. In voltage measurement mode, the meter has a very large resistance approaching infinity and therefore doesn't perturb the circuit. And this will be used to measure the voltage being applied by the first meter. So the setup will be the same. I'm going to use the prototyping board that we used in Part 2, the same resistors just rearranged. And note that I now have two of the resistors arranged in parallel, and the other two are in series with the parallel pair. So that is going to be the nature of the measurement process. I'm going to use the buses in this particular demonstration just so you become familiar with their use. So you'll notice on the breadboarding region that I have connected the opposing ends of the resistor array to the bus. The red and the green are going to designate the high and the low. So the green is going to be attached to the upper bus. The red is going to be attached to the lower bus and represent the high. I will connect the buses to the banana jacks above in the upper right hand corner of the proto board. And in so doing, what I will eventually have on the board is this circuit with the yellow indicating the conductors. And then, as you would imagine, the resistors themselves would correspond to the cartoon resistor, the Charlie Brown stripe, so to speak. Domino has kindly set up the experiment on the floor, and you can see where the wires are running on the proto board. So the buses have got additional wires now running to the banana jacks, and the banana jacks are attached via the appropriately colored cables to the DVM. So red is high, and you can see how follow the cables to the bus and to the bottom of the resistive array. And then low or common is going to be the green wire connected to the black cable or the black banana jack interface and the black input on the meter. Now in the resistance mode, the meter is reading 4214 ohms, so 4,214 ohms for the total resistance. And knowing my cats as I do, I suspect that the odd resistor has been put into the parallel array just to mess with me. This is just a different view of that same setup. You can see where the wires are going. So those banana jack things have a plug for the banana jack, and those mounts turn on a screw that you can attach the wire directly. So you can see where Domino has more or less run the wires. Suspecting as I do that the cat has sabotaged the experiment, I'm going to make some predictive calculations just to get a sense of what I expect to see. So what I suspect is that the cat has paired the outlier resistor on that 4 resistor set with one of the other resistors just to make it difficult for me to make the measurement and make the calculation. So using the parallel resistance laws, I can calculate the expected resistance value of the parallel array with one of the resistors being the 1005 resistor. Doing that, I get 643 ohms as the predicted resistance of the parallel resistor pair. If I have guessed wrong and it's actually the 1789, I still get the same value. There's no significant difference whether I have the 1782 or the 1789. If I happen to have two 1789s in parallel, the cat does a double cross, I would expect to see 894 ohms as the resistance of the parallel array. So now I can, with this prediction in mind, I can calculate the total resistance value by taking the two 1789s and putting those in series with the parallel 643 ohms, and I get 4221. Recalling now that my measured value was 4214, so cat, I've got your number. And I notice there is a discrepancy. I'm just going to make that now. So the discrepancy is only 0.1%. So the fact that I'm getting not a quite match is not a big deal here. Now proceeding, what I want to do is use these values to predict what the voltage drop would be across each of the resistors in that series of two single resistors in series with the parallel. And these are going to be my calculations. So all I've done is applied Ohm's law. The voltage applied, which I have not yet measured, or the cat has not provided me with the second DVM yet. I will plug this in and I will predict the voltage drop across resistor 1, the parallel pair, and then the third resistor in that series array. I now have my setup. On the right, I have the DVM that is set to resistance mode and will therefore apply the voltage to the network set up on the protoboard. And it measures a 4,212 ohm resistance across the array, as we described previously. The meter on the left now is measuring voltage, and recognize that high and low are inverted as a natural order type thing. So low is at the top, and the voltage being applied by the meter on the right is 418 millivolts. If I take that applied voltage, namely the 418 millivolts, and insert that into my predictions, my equations that were going to give me my predictive voltage drops, I see that I expect, assuming that I have actually predicted what my cat is going to do, the voltage drop across the first resistor will be 177 millivolts. The voltage drop across the parallel pair will be 64 millivolts. And the voltage drop across the third resistor will be 177 millivolts. The measurement across the first resistor, in fact, is 177 millivolts as predicted. The voltage drop measured across the parallel pair of resistors is 64 millivolts as predicted, looking good. And the voltage drop across the third and final resistor in that array is 178 millivolts, which is as predicted, only 1 millivolt different, which is within the error range and the discrepancies in the resistors. So this is looking particularly good. It looks like I have correctly predicted what my cat is going to do to me. And so in conclusion, what I have done was arbitrarily set up a resistive network that has three components: two single resistors in series with a parallel pair, which I've called resistor 1, the parallel pair, and resistor 3. Knowing the resistance values and creating this scenario where the cat actually assembled the circuit, I predicted, based on Ohm's law, what I would expect to see by way of a voltage drop across the network. The demonstration part of this laboratory has been to actually make the measurements, and I verified that the voltage drop across the first resistor was in fact 177. The voltage drop across the parallel pair, based on the theory of parallel arrays, was in fact 64 millivolts. And finally, that the third and final resistor had a voltage drop of 178, which is consistent with what I predicted. So the whole point of this was to show you how to make the measurements, how the measurements actually jibe with the theory, and essentially describe how one goes about prototyping and testing circuits. So part 4 will deal with a bridge.